everyone, welcome to my channel Rahman Tutorials. In this video we are going to learn about chemical reactions and equations, chapter 1, part 1, class 10. Consider the following situation of daily life and think what happened when burning of coal into ashes to provide us energy. Milk is left at room temperature during summer turns to curd. When iron is exposed to humid atmosphere, gets rusted. Burning of coal, milk to curd, rusting of iron, or a result of chemical reactions can be represented through chemical equations. Let us see what a chemical reaction is through experiment. We begin with some zinc granules in a conical flask. These granules are blue-grey in color, fitted to hold rubber cork on this flask. Then we fit a thermometer through one hole of the cork and the thistle funnel at the other hole. Next, pour 5 ml of diluted sulfuric acid into the conical flask through the thistle funnel. Of zinc granule changes from blue-grey to white, some gas bubbles were also released from the solution. This is because zinc reacts with sulfuric acid to form zinc sulfate, salt, and hydrogen gas is released. Zinc sulfate is white in color. The thermometer shows an increase in the temperature of the solution. Therefore, as you can see in this experiment, the color of zinc changed during the reaction. That is, there was a change in physical properties. The reaction also resulted in the evolution of a gas, that is, the form of reactants change. Zinc reacted with sulfuric acid to form zinc sulfate, a salt. Thus, the composition of the reactants changed. Hence, we can say that a chemical reaction involves a change in the physical and chemical properties, the composition and the physical state of a substance, whether the element or a compound. Chemical reaction is typically expressed in terms of chemical equation. The chemical equation indicates the component in a reaction, the physical state of reactant and a product of reaction. Thus, a chemical equation is a symbolic representation of the reactants and the products using their chemical formulae. For example, zinc reacts with diluted sulfuric acid to form zinc sulfate, a salt, and hydrogen gas is evolved. This is represented in the form of equation as shown here. Solid zinc reacts with diluted sulfuric acid to form an aqueous solution, zinc sulfate, and hydrogen gas. The chemical equation is made of the following components. The reacting substances known as reactants are written on the left hand side. For example, in equation saw, zinc and diluted sulfuric acid are reactants. Therefore, they are on the left hand side of the equation. Resulting substances known as products and are on the right hand side. For example, in the above equation, zinc sulfate and hydrogen gas are the products. Hence, they are on the right hand side. An arrow separates the reactants and products and also indicates the direction of the reaction. Thus, in the equation you saw, the arrow indicates zinc and sulfuric reacts to form zinc sulfate and hydrogen gas. Let's take another example that involves two substances. In the burning of coal, carbon reacts with oxygen to form carbon dioxide. In this reaction, carbon and oxygen are the reactants and the carbon dioxide is the product. The chemical equation for this reaction is as shown. Solid carbon reacts with oxygen gas to form carbon dioxide gas. In chemical equations, we denote a solid with S, a liquid with L, a gas with G, an aqueous solution with AQ, a gas produced with an arrow pointing upward, precipitate form with an arrow pointing downward. The reactants and products were separate with an arrow which points in the direction of the reaction. Let us consider the reaction of iron with steam. Solid iron reacts with steam to form solid iron oxide and hydrogen gas. This reaction is represented as shown. A symbolic representation of the chemical reaction is the first step in writing a chemical equation. The next step is to ensure the equation is balanced considering the law of conservation of mass. The law of conservation of mass states that total mass of the reactants and the product should be equal. This means the number of atoms of an element on the reactant side should be equal to the product side. All chemical equations must adhere to the law of conservation of mass. Therefore, all chemical equations need to be balanced. The process of balancing the chemical equations involves 4 steps: determining the reactants and the products in a reaction, counting the number of atoms of each element on both the sides, selecting the elements that occurs the least number of times in the equation. Balancing typically starts with such elements where the number of atoms is not equal on both sides. Changing the coefficient of the molecules of the reactants or the products as required. You should continue balancing the atoms in this manner till you have covered all the elements in the equation. In the end, do a final check to confirm that the number of atoms on the reactant side and the product side have been properly balanced. Here is a word of caution. When you balance equation, use coefficients only on the left side of the symbols of the elements and compounds. Never change the formula of the compound or element to balance an equation. To understand how the equation is balanced, let's refer back to the reaction of hydrogen with oxygen to form a molecule of water. We need to balance this reaction according to the law of conservation of mass. The first step is to determine the reactants and the products in the equation. Here, hydrogen and oxygen are the reactants. Therefore, they are written on the left hand side. The water molecule is the product, hence it is written on the right hand side of the equation. In the second step, you need to count the number of atoms of each type. You notice that hydrogen has 2 atoms on the reactant side and 2 atoms on the product side, but oxygen has 2 atoms on the reactant side and only 1 atom on the product side. So, there is 1 oxygen less on the product side. According to the law of conservation of mass, the number of atoms on the reactant and product side should be the same. In step 3, you need to select the element that occurs in the minimum number of places in the equation. You can see that there are 2 hydrogen atoms on each side while there are 2 oxygen atoms on left hand side and only 1 oxygen atom on the right hand side of the equation. Hence, oxygen has to be balanced. First, finally in step 4, you change the coefficient of the molecule of the reactant or the product. To do this, you need to first select the oxygen atom and balance it by placing the coefficient 2 before the product water molecule. Now, there are 2 oxygen atoms on the reactant side and 2 on the product side. However, placing the coefficient 2 before the water molecule gives 2 hydrogen atoms on the reactant side and 4 hydrogen atoms on the product side. Thus, there is an imbalance in number of hydrogen atoms. To balance the hydrogen atoms, place the coefficient 2 on the left hand side of hydrogen atom on the reactant side. Now, let's take a look at the final equation. The atoms of each elements on the left hand side and on the right hand side of the equation are now balanced as per the law of conservation of mass. According to the final balanced equation, 2 molecules of hydrogen react with 1 molecule of oxygen to form 2 molecules of water. Let's practice further with balancing equation with another example. This equation deals with the combustion of ethyl alcohol. Again, the first step is to identify the reactants and the products. Here, ethyl alcohol and oxygen are the reactants as they are written in the left hand side of the equation. The product on the right hand side are carbon dioxide and water. Step 2 is to check the number of atoms of each type on either side. Here we have 2 carbon atoms on the left hand side and 1 on the right hand side. 6 hydrogen atoms on the right hand side but only 2 hydrogens on the right hand side. 3 oxygen on the left hand side and 3 oxygen on the right hand side. Let us begin balancing equation by selecting carbon. There are 2 atoms of carbon on the reactant side but only 1 atom on the product side. So to balance this, add the coefficient 2 before the carbon on the right hand side. Now let's consider hydrogen, the next element. There are 6 atoms of hydrogen on left hand side and only 2 hydrogen atoms on right hand side. To balance this, you need to place the coefficient 3 before the water molecule on the product side. Now, as you can see, hydrogen has been balanced. The next element in the equation is oxygen. There are 7 oxygen atoms on the product side but only 3 atoms on the reactant side. To balance the equation, place the coefficient 3 before the oxygen on left hand side. In the end, do a final check to confirm the atoms is balanced on both the sides. Here is what you get as the final equation. Ethyl alcohol reacts with 3 molecules of oxygen to form 2 molecules of carbon dioxide and 3 molecules of water.